So in the previous video, what we saw was how wave theory could not explain the photoelectric effect and how light behaves as a particle. Now in this video, mainly what we are concentrating is why this particular photoelectric effect happens whenever light hits it and how light behaves as a particle. Now coming to this, so when photoelectric effect was discovered, many people came up with different types of explanations for it. But one person succeeded in explaining it, and his name was Albert Einstein. So what Einstein told was light is not a wave in this case. Light behaves as a particle. So he didn't name it as particle. What he told was that light is packet of energy which is moving with a very high speed. And he called these packets of energy called as photons. So photon is basically a packet of energy. Now what we call it as that one photon has one quanta of energy. Now this word quanta was coined by very famous physicist Max Planck. So a photon has a quanta of energy. So to figure out the energy which is there in a photon, we have the formula E is equal to h nu, where h is Planck's constant. So Planck's constant is given by 6.626 into 10 to the power of minus 34 joule second. Now for calculation purposes, we can take it as 6.63. Alright, so this is Planck's constant, and nu is the frequency in which the light is coming, the photon is coming. Now see, what we have is that light behaves both as a particle as well as a wave, correct? So it should have the wave property. Now since we have nu, the frequency, see, we have C is equal to nu into lambda, where lambda is wavelength. So nu is equal to C by lambda. So when we substitute that, we get E is equal to hc divided by lambda. So this is the energy of the photon. Either we can use E equals to h nu or E is equal to hc by lambda. Now this is the energy. Now coming to the momentum, because if light is behaving like a particle, it should have a momentum, right? So momentum is given by h divided by lambda. Okay, so P is equal to h by lambda. Now see, there are certain properties of photon, you can say. Alright, see, first property, very important property, is photon is moving with the speed of light, okay, which is 3 into 10 power 8 meter per second. Second property is the rest mass of a photon is 0. So what is rest mass and all those things you guys will learn later. So for now, just remember, photon has a rest mass of 0. Third point, a photon is electrically and magnetically neutral. So electric field and magnetic field has no influence on it. Alright, so these are certain properties of photon. Now we talked about how light behaves as a particle and why photoelectric effect happens, right? Now what contribution did actually these two people, Einstein and Max Planck, what did they do? So we'll see that in the next video.